Okay, please go ahead and complete the warm-up. So go ahead and pause the video at this time. All right, this is the a warm-up that reviews a lot of the material we've already completed. The first, letter A, if an item is picked at random, find the probability that the item is defective given that it came from the day shift. So the total number of day shift items are 220. And that number that were defective was 20 out of 220. So that came from right here. The item was not produced at night. Well, at night it was 140. So it was 1 minus 100, minus 140 over 600, which is 460 over 600. The item was defective or it was produced in the evening. So this is the addition rule if you choose to use that. So defective or in the evening is going to be the probability of defective, which is 85 out of 600, plus the probability of evening, which is 240 over 600, minus the ones that counted twice, those who counted both for defective and evening, which was 25 out of 600. And that total is 300 over 600, or 1/2. 3 items were selected with replacement. Find the probability that they are all defective. So the probability of defective is from this total here, 85 over 600. And we were replacing. So these become independent events. So there's 3 of them. So it's 85 over 600 times 85 over 600 times 85 over 600, which is 85 over 600 to the 3rd power, or 0.0028. Using the definition of independent events, are defective items and items made at night independent? So for that to be true, the probability of defective is going to have to be equal to the probability of defective given that was made at night. Or you could do probability of night is going to be equal to probability of night given defective. Both would work. So defective was 85 over 600. And defective given that it was produced at night. So at night was 140. And that was 40 out of 140. And I hadn't already done this, so let me take out my calculator. So 85 divided by 600 is 0.14. And 40 divided by 140 is 0.285, which is about 0.29. Since they are not equal to each other, they are not independent. Okay, moving on to the next page. These are the homework answers, so you should have already checked those for homework last night. The answers will be on Edline if not. All right, we are now on page 43. And what I would like you to do right now is to complete questions 1, 2, and 3 on page 43. So please pause the video at this time. Okay, on page 43, a cereal company puts toys into boxes. So if you bought 1 box of cereal, estimate your probability of getting the toy airplane. Well, out of the 4, there is a block, a toy watch, a toy ring, and an airplane. So there's only a 1 in 4 probability of selecting that, whether you're picking it on the first box or a later box, because each choice is independent of one another. Whoops. And then we're going to go ahead and move down here. Number 2, if you bought a 2nd box of cereal, what's your probability of getting the toy airplane in the 2nd box? So again, so that's an independent of the box before. So that also is a 1 in 4 probability. Now what they're asking you to do is to think of every possible outcome. And what I tend to do for this, selecting both out of both boxes, is you have a block W R, and then A for airplane. You can make a tree diagram to come up with your outcomes for each one. Or you can just think through what they might be. So again, that would be like a B, a W, an R, an A, a B, a W, an R, an A, a B, a W, R, an A, and one more time. So what they would like you to do is actually go ahead and list all those outcomes. So my outcomes were, it's just listing what you have there, a B and a B, a B and a W, a B and an R, B and an A, and then a W and a B, a W and a W, a W and an R, a W and an A, an R and a B, RW, RR, and an RA, and finally an A and a W, an A and an A and a B, A and a W, A and an R, an A and an A. So these are all, this is called the sample space when you list all the possible outcomes. All right, go ahead and flip onto the back of that sheet, which is going to be page 43. So find page 43. From the list we created, what we want to find is the probability of getting one and only one airplane. So again, from your list of possibilities, we only got one and only one airplane 6 times. So this is 1, 2, 3, 4, 5, 6 times. And you can see that this easily shows you that there were 16 outcomes as well. So this is 6 over 16. At least one airplane means one or more airplane. So it's this plus the one case where you had two airplanes. So this is 7 over 16. And then the complement of that would be the probability of no airplanes. So that's going to be 9 over 16. And again, if you need to go back and look at those outcomes, that would help out here. Okay, airplane in the first serial box, again, that's the first question we answered earlier, which is 1/4. And airplane in the second box is still 1/4. Again, those are independent events, and they happen without regard to the one that happened before. We saw airplane in both serial boxes. If you look at the outcomes 1 out of 16 times, or you can use the multiplication rule and do 1/4, which is the probability of airplane in the first, times 1/4, which is the probability in the second. Then they ask if the events are independent or dependent. And we've already talked about the fact that these are independent because what we choose in the first box is not going to influence what we get in the second one. They are asking which rule applies, and this is the multiplication rule for independent events. So what we did in question number 4 is we were able to multiply those two outcomes. So if we are looking for the probability of A and B, that is going to be equal to the probability of A times the probability of B. Go ahead and flip to your next page. They are talking about the situation of life is like a box of chocolates. Please go ahead and complete, stop right now and complete numbers 7 through 13 on that page. So please pause the video. Okay, we are back. If you randomly select one piece of chocolate in the box, there are 15 identical pieces. What's the probability that the piece will be filled with fudge? Well, there were 4 pieces of fudge, so that's going to be a 4 out of 15 probability. Suppose the type of filling underneath is named underneath each piece, and since you don't like fudge filling, you put back the fudge filling piece without biting into it and then randomly select that piece. What's the probability that the second piece will be filled with caramel? This is independent because we replaced the first one, so there's still the same number of chocolates in that box and the same numbers of each type. So caramel up here was 3 caramel, so this would be a 3 out of 15 for the probability. If A sub 1 is the event of picking a fudge-filled piece on the first selection, and B sub 2 is the event on the second, or caramel on the second, we want to determine what A of 1 and B of 2 with replacement would be. So fudge on the first is 4 out of 15. With replacement means we still have 15 and all the same that we had before. So we're going to replace it. And then caramel on the second is 3 over 15, which is going to give you, 12 over 225. Are they so they are going to be independent events because the first one is replaced before you choose the second one. Okay, so now we're starting to get into some dependencies here. So if the first if instead you randomly select a piece of chocolate after you have eaten the first fudge filled one, so there's only 14 left now. Because you love fudge filling, what's the probability the second will be filled with caramel? Well, there are still 3 caramels in the box, but there are only 14 candies that are actually there right now. So that probability is 3 over 14. Number 12. We are trying now to find A of 1 and B of 2 without replacement. So fudge on the first one is 4 over 15. We are not replacing, so there are still 3 caramels, but there's only 14. Whoops, why are you going all the way over there? 14 pieces of chocolate in there. So that's going to be, if you multiply it at 12, over 210. And these are what we call dependent events. On the back of that sheet of paper on page 46, does the rule you cited in number 6, which is the multiplication rule for independent events, apply in the scenario in which you replace the first chocolate in order to select the second chocolate? And the answer to that is yes, because those are independent events. With replacement, the events are independent. All right, down below, your mom has a rule that whatever you take, you eat. So whenever you take a chocolate from the box, you eat it. What is B of 1 and A of 2? That is asking for what's the probability of a caramel first and a fudge second. So I think I wrote this wrong on my answer key, but there were caramel. There were 3 caramels. So this should be 3 over 15. And fudge on the second is 4 over 14. So you've eaten it, so it's now gone. And that is going to be 12 over 210. If C represents a coconut-filled piece of chocolate, A of 1, which would be fudge on the first one, which is 4 over 15, and coconut on the second. Well, there are 14 pieces of chocolate left, as we talked about, because we've already eaten one, and then there's 2 pieces of coconut in there of those chocolates. So that's 8 over 210 for our probability. All right, find the probability that both the first and the second piece are filled with chocolate whip. Well, if there are 4 chocolate whip, so that's 4 out of 15. But we've eaten one of the chocolate whips, so there's only 3 of those left out of the 14 pieces of chocolate there. So you multiply that out, and that's your 12 over 210. Now it wants a general probability of rule that works in the case of replacement. Okay, so in the case of replacement, the probability of A and B, wow, look at that, is equal to the probability of A times the probability of B. Now, I'm going to just introduce this now. Without replacement, the multiplication rule changes. And this is going to be equal to the probability of A times the probability of B, given that A has occurred. And that should make sense in terms of what we did here. You know, we had to change that probability of the second chocolate whip based on what we got on the first one. So it depends on what you chose for A. That influences the probability of B. In the slide chart, if you were looking on in class here, there are some, we looked at this the other day, where we're looking at the conditional probabilities and the relationships to these formulas. So, we are now on page, looks like page 47. So they are asking you to look at those questions. I'd like you to complete page 47 right now, so pause the video. All right, you are back. You are determining whether they are independent or dependent and what the probability is. So we're now using those two probability rules. So selecting a 6 from the first draw and a 2nd on the second draw when the two balls are selected without replacement. So that is dependent. And there's 10 balls, so 6 on the first one, so there's going to be a 1/10 chance of that. And then a 7 on the second draw. Well, there's still 1 7, but there's only a total of 9 balls in there. So that probability is 1 over 90. Okay, down below. Probability of selecting a 6 on the first and a 2nd on the second when the balls are selected with replacement. With replacement is independent. And that's 1/10 times 1/10, which is 1 over 100. Third one, the probability that 2 people selected at random in a shopping mall in a very busy Saturday have a birthday in the month of June. So out of the 365 days of the year, there are 30 days in June. So there's 30 days where they could have a June birthday. So that's the probability of the first person selected at random having that birthday. It says all equally likely to ignore the possibility of a leap year. So probably 2 people selected at random, and then this is from a very large ball on a very busy Saturday. So you're assuming, again, that that's the first person, and then the second person would also have a 30 over 365 chance of selecting or being selected with the June birthday. So that's going to be 0.0068 when you simplify that. So 30 times 30 over 365 times 365. The probability that 2 socks selected at random from a drawer containing 10 black socks and 6 white would be black. Okay, so this is dependent because it's not indicating that we are replacing them back. So there are 10 black socks out of the 16, and then when we choose our second one, there's only 9 left in there, and a total of 15 socks. So that's 90 over 240, which is approximately 0.375. Back of that sheet, take a minute to look at number 2 and number 3. Pause the video at this time and go ahead and try those problems. Okay, you are back. A gumball machine has sour apple, grape, orange, and cherry. There are 6 of each, and they're indicating the events. C of 1 means cherry on the first, C of 2 is cherry on the second, etc. So, probability of C of 2 given C of 1 is the probability that the second is cherry given that the first is cherry. Whoops. Now they want you to find the probability that the first is cherry and the second is cherry. So this is, you're in a gumball machine, so you're not going to be replacing. So first, cherry is 6 over the 24 that are in there. Is the first one being cherry? We already have a cherry selected, so and out of there. So there's only 5 cherries left out of the 23, which is going to give you 30 over approximately 552 when you multiply that. Let me move this down. The next event is apple on the first and grape on the second. So there are 6 of each type, so there's going to be 6 apples on the first choice, and then 6 grapes on the second choice, but only a total of 23 gumballs, so that's 36 over 552. Finally, down below, these are different types of blood types in the United States and the percentage of which people have them. So considering a group of 100 people with a distribution of blood types consisting of these percentages, if any two people are randomly selected, what's the probability that both people have type O blood? So type O blood is 0.44, or 44 out of 100. And then the probability that they both have is 0.44 times 0.44. I have no idea why I drew that line. Just ignore that. And that's 0.44 squared, or 0.1936. Again, they're asking what the probability is, not how many. The first person has type A blood, and the second person has type AB blood. Again, type A is 0.42. Type AB is 0.04. And you multiply those and get 0.0168. Those are independent events. Now it's time for you to start your homework if you have any time left in class. And this shows you, again, the general multiplication rule that we talked about. And we talked a lot today about independent and dependent events for multiplication rule. So tonight's homework is page 49 through 53, so it's 4 pages. Please have that done, and thank you very much.